Practitioners working with individual sport athletes are better positioned for individualizing training and using case study-based approaches with individual athletes than those working with team sport athletes. However, despite these advantages, practitioners working in individual sports should avoid monitoring athletes just for the sake of monitoring. Access to technology and specialized equipment is not a prerequisite for athlete monitoring. As noted throughout this course, there are many monitoring tools that enable practitioners to obtain important information about their athletes, but not all of them are expensive. In other words, a large budget is not necessary to set up an athlete monitoring system. Simple things can be done with a limited budget. For example, tracking aspects of athlete training performance with a paper and pen. Following are some monitoring tool ideas if you are on a budget. The first one is a training diary. Athletes can document all aspects of training, including duration, intensity, and type. Intensity classifications. Even without technology to measure heart rate, practitioners can create classifications to rate session intensity. Individualized records. Get the athlete to monitor factors that could impact training and recovery. This could include injury and illness, competition results, recovery strategies, and life events, such as school exams. Session RPE. Athletes can record their RPE for each session as a measure of internal load. And other metrics may include aspects such as training load, monotony, and strain, which can be determined from session RPE and training duration. Then there's wellness questionnaires. Practitioners can design their own questionnaires according to the questions that they want to get from their athletes. And then there's also the readily available published questionnaires that we've been through in previous modules. And these could include the POMS and the REST-Q Sport. There's also visual analog scales. These can be used to measure athletes' current levels of perceived fatigue, recovery, and soreness. Counter movement jump or broad jump tests. A tape measure could be used to determine jump height or distance. The stopwatch, used to measure performance times such as sprint. And then the collection of composites of several critical aspects of training, and these could be used to calculate training performance scores. For example, Agostino and colleagues developed a global training performance metric for judo athletes that took into account the intensity of key exercises and throws. Then there's also appropriate analysis methods. The smallest meaningful change in monitoring variables can be calculated for each athlete using appropriate baseline data. This process requires only a calculator or a spreadsheet. Practitioners can use simple tools such as Microsoft Excel or Google Docs to develop their own monitoring templates. Google Docs allow practitioners to develop their own training diaries and questionnaires that athletes can access on devices or their smartphones. Moreover, questions can be presented in a variety of formats and layouts. Advantage of using simple tools such as this is that data reporting is relatively straightforward. Practitioners requiring more advanced analysis can convert the data to a CSV format. Although these systems require an initial time investment on the part of the practitioner, they can be very beneficial. As with any monitoring approach, it is advisable to begin with a simple set of questions and build on and refine them as needed. In summary, using simple tools, practitioners can set up relatively sophisticated monitoring systems. The value of monitoring data is determined by how they are analyzed, interpreted, and implemented. Ultimately, a successful system is one that informs practitioner decision-making and improves athlete performance. Data obtained from training diaries can be informative for the practitioner, and the process is simple. For example, an analysis of the training diaries of Olympic track and field athletes provided insights into the volumes of strength and power training across a year. In this analysis, it was showed that 50 to 60% of combined strength-based, that's high load, and power-based training volume undertaken in the preseason was enough to maintain strength and power throughout the 3-month in-season competition. Assigning training loads during the season is an important consideration for practitioners. Retrospective analysis of training diaries can guide future training program design. Fundamentally, at issue is not just the total training load, but how the athlete gets there and how to vary the load across the season. Obtaining this information from simple training diaries can have implications for both performance enhancement and injury prevention. Research studies that involve training diaries typically span periods of less than 1 year, although case studies have been published on single elite athletes for longer periods of time. Keeping training diaries for several years or longer could provide rich details about athletes' evolution and reveal pictures of their training practices at various levels. Youth athletes, for example, could examine the training that elite athletes go through to see the intensities and loads they build up over time to arrive at their elite level. Further, athletes could compare training using different modes of exercise. A training diary can reveal the differences in volume and intensity between aerobic endurance training and resistance training. Aerobic training volume, such as the distance covered during a week at a certain intensity, as in this case, for example, a percentage of VO2 max, can be contrasted with the volume and loading of resistance training. Such analysis can help practitioners formulate training models for athletes. Another way athletes keep track of their training is to record the intensity of their workouts based on zones. Ideally, these zones are based on physiological measures such as heart rate. One researcher outlined 5 zones when documenting the training practices of elite distance runners. The zones were 1 equals easy and continuous running at 62 to 80% of maximal heart rate. Zone 2, threshold training, 82 to 92% of maximal heart rate. Zone 3 was called intensive anaerobic intervals at 92 to 97% of maximal heart rate. Zone 4, anaerobic training, greater than 97% of maximal heart rate. And Zone 5, classified as sprinting. Using this approach, the practitioner can obtain a clear picture of the type and intensity of sessions simply by looking at the athlete's zone number in the training diary. As long as the practitioner or the athlete documents the intensity in some manner, such as RPE or zone, a measure of internal load is available. The other factors that require consideration are the athlete's level of experience and his or her individual characteristics. For example, Tran and colleagues analysed the training practices of elite Australian rowers leading up to the 2012 Olympic Games. They documented external load by measuring training frequency, duration, and total distance rowed on the water and by using ergometers. Other forms of training, including resistance training and cycling, were also documented. Internal load was measured using an adaptation of the training impulse method. Published research can give practitioners insights into the training practices of elite level athletes. Importantly, published studies providing data on both external load, such as training dosage, and internal load, training responses, can be particularly informative. In summary, the effective monitoring of individual sport athletes can be accomplished with simple, cost-effective tools. The insights gained from these monitoring practices are invaluable for enhancing performance and guiding injury prevention strategies. The goal of this video was to underscore the importance of adopting a tailored and analytical approach to athlete monitoring, ensuring practitioners and athletes alike can achieve their peak potential.